And hello, welcome to today's webinar. For those of you who aren't familiar and don't know who I am, my name's Elliot, part of the technical support team here at Reusable headquarters in Germany. And you'll notice actually alongside me this week is Ugo, also part of our support team. So today's webinar is taking a slightly different format. Today we're going to be talking about our hardware applications, what we offer here at Reusable, and the best applications for different types of events. And so we do have our chat in front of us, so please do send us your questions, and we'll actually try and answer the questions a bit more as we go through, at each topic in between as we go along. So I'm going to start off. There we go. So as I said, we're going to first look at all the hardware we offer here at Reusable, and we offer both passive and active timing solutions. So to give you an idea of what that means, we have our 5000 series decoder, and you can either run passive timing off this. We'll go a bit more into what passive timing is. But generally speaking, this uses our ground antenna, which was laid out on the ground. It reads the chips, and we offer both reusable and disposable tags. So the most common passive timing is the chip on the bib. So things like marathons, where you see the transponder on the bib. But we also offer shoe tags and reusable ankle tags in our Hue tags, and also just tags on a roll that you can use for helmet tags or seat post stickers or any other application you may think of. The other side to this is the active side, so you can connect the active extension to our decoder. So the decoder offers both passive and active capabilities from one system. So the active system works in a slightly different way. There's no antenna as such that reads the chips, but the loop across the ground which activates the transponder, and the transponder sends the data back to the active extension. There is the little brother of this, the USB time box, which, as the name suggests, connects via USB cable. We have a range of transponders with different specifications, our loop box, trap box, and management box as well. And Ugo will talk a little bit more about the other devices to go with our active system a bit later on in the webinar. But I'm going to start off now, and I'm going to talk about the passive system. So as I mentioned, and you can see on the screen now, our passive system is based around a single decoder with a ground antenna map. So generally, passive systems are used for mass participation events. These are large events with lots of people, as the name suggests. And that's because it's not necessarily feasible to give everybody an active transponder due to the cost of them. And the chips can be thrown away afterwards in most cases. They're also often low-speed events, so there is a speed limit with passive systems, and we generally say up to around 40 kilometers an hour. We do have some people who go faster, but the thing to note is that the passive system is less accurate. That's the limitation of a passive system and all passive systems. So our system, we claim accuracy to 0.2 seconds, which obviously if you're in a high-speed sprint finish probably isn't going to be adequate. That's why lower speed, where people are going slower, you can much more easily get the accurate time. And as talked about, we offer both disposable and reusable chips. So reusable is our reusable shoe tag or our Hue tag, whereas our bib transponders can be thrown away afterwards. So the cost is much cheaper in that respect. So the kind of events you might use a passive system at, running events, pretty much all running events, you know, from your local 5K through to marathons or ultra marathons, can use a passive system. The only one that can't really is like an athletics event, so a 10,000 meter on a track or 100 meters, because you just don't have the precision that's required, and the governing bodies would not allow a passive system for that use. In fact, they generally require a photo finish, so that's why you won't use it in athletics. Low speed cycling events, so road cycling sportives or grand fondos, where it's not a competitive race with high speed sprint finishes. But it could be used for mountain bike cross country events. These are generally slightly lower speed, and you can still get the accuracy required at that level. Although again, at a litre level, you may want to use an active system. And obstacle races. So these are become more common around the world, won't name any in particular. But you could use a passive system, either with our Hue tag or disposable triathlon tags. I wouldn't use something like a bib for this, bib with chip, for the simple reason that with the obstacles and the nature of them, the bibs and tags can easily get damaged, but something that's worn on the ankle is generally a bit safer and can be used for an obstacle race. So I'll have a quick look at some events that have been using our passive system so you can get a better idea as well, and we'll talk a bit about some of them on the way. So the first one I'm going to look at here is a mountain bike cross-country race. This was the UCI Mountain Bike Marathon World Championships, according to the sign. And you'll see it's using the passive antennas here. But you'll notice these riders are very close together. And actually there was less than a second between these three. They weren't fighting for first place, they were lad. But even with the passive system, the times were accurate. So these used mountain bike plates with the transponders on the back of the mountain bike plate, and the placing was also correct too. So you can use it at mountain bike races. We have the Rock and Roll Marathon Series in the US, which I'm sure many people will be familiar with. So these events offer everything from a 5K, 10K, half marathon, marathon, and the largest one they've had this year is 26,000 participants so far. I think our largest that's used our passive system is over 30,000, but you can see there where a passive system with disposable chips is super convenient, and these guys are actually using 16 meters wide. I'm not sure if you can quite see the double set of mats there, but it allows for a 60 meter wide finish line, and they had a main and backup system. Another running event is a particularly wet looking Swansea half, so you know, a slightly smaller event, still reputable, but you can see our passive antennas in use here as well. And they had, I think, 3 or 4 split points on the course as well. Triathlons. So triathlons, generally speaking, most of the time I would personally use an active system, but there are times that's not feasible. If you've got 2,000 participants in a triathlon, it may not be possible from a financial point of view to use an active system, and a passive system can offer a good alternative. You do need to remember some of the limitations of a passive system. So for example, if you're using wetsuits on top of transponders can cause problems. So you need to plan your setup well, and if you put it right next to the swim exit as well, you may have a few misses, and that's due to the nature of a passive system. There may also be cases like the organizer doesn't want the mat on the road for cyclists, so you may not be able to get the bike splits, but we've both done that before, so it can definitely be used, and we were using it at the Triathlon de Paris. This was last year. Excuse my French there, Hugo. And how many participants was this one?
1,800, 2,000.
There we go, and it was used very effectively in that race. So that's the passive side of things. There's no questions coming yet, so either I've answered everything or no one's got any questions about passive. And I'll pass over to Hugo, who will talk more about the active side of our system.
So, as Elliot rightly explained, our passive system is for mass events at lower speeds. So whenever you have an elite event or higher speeds, you may want to go for our active system. Historically, the first 2 devices we released with the active system was the active extension that's built as an extension of our existing passive decoder, as the name indicates, and the loop box. So the decoder and the active extension act as the main system, and you can use the loop box to either repeat detections in real time to the main system when it's within range, typically a few hundred meters, or to store the detections in the chips. There's a smaller version of that active system, which is the USB timing box. As the name indicates, the USB timing box connects straight to your laptop with a USB cable, so there's no need for a decoder, making it a very lightweight solution. You could travel to a triathlon with one USB timing box and 2 of these loop boxes, and you'd be able to time it. Here you see that each of these devices need a loop taped to the ground. So actually that loop that you see here would be unrolled and taped to the ground. And this activates the chip. Once the chip is activated, it transmits its detection via 2.4 gigahertz to this black antenna. In some special cases, when you have really high speeds or a high density of participants, you may want to replace this 2.4 gigahertz antenna with our range extender, which is in the shop. So you can move the 2.4 gigahertz antenna higher to receive detections from the chip in a bigger range, and also have better communication with your loop boxes if you're deploying some. If you have any questions regarding the range extender, I'll be happy to answer them. Last but not least, in our active system portfolio, we have this green box, which is the management box. Initially, this was designed just to manage your chips, create chip files easily, and also to set your chips to deep sleep during the low season, so you save some battery life. And now it's also an important part of our tracking system, which I will explain a bit more now. So a tracking solution consists in this track box. Once tracking mode has been enabled on the active transponder using the management box we've seen in the previous slide, then track boxes along the course are able to pick up all the track pings from these chips within a 15 meters radius minimum. Typically, we'll expect to get track pings from 150 meters out, or depending on the environment, you can get track pings from as far as 500 meters. So using this track box, you can, of course, collect a lot more data, which you will typically use for tracking visualization. But you can also use these as timing systems for timing points where the accuracy is not as critical, because we've actually tested these against decoders on some bike splits on triathlons, and we've experienced time accuracy compared to the decoder. Generally, they were on the same second. Sometimes the times were like 1 or 2 seconds off. So if you just want to know if a participant was at a timing point and roughly at what time, that's a good tool. Whenever you need accuracy, then you'll need a traditional timing system, either a loop box or a decoder or USB timing box. So, what kind of events do we use the active system at? Generally, elite events at high speed, and the specs. So it's a lot more accurate and reliable than the passive system. So with the active basic, you get actually the same accuracy as with our passive system, but it's 100% reliable. With the Active Pro, you'll get 1/100th of a second accuracy with the right setup, and with the Active Motor Transponder, you'll get 4/1000th of a second. The big difference between active and passive chips is the chips carried in their own internal battery and memory, which explains also the difference in price.
So one interesting thing there, Hugo mentioned elite events. So it's quite common in major marathons, for example, that actually the elite athletes will use an active transponder. So they'll have both active and passive systems running simultaneously. So the elite athletes have the active, and then the 40,000 other participants will use a passive system. So that just shows how elite events really do require that high accuracy, high precision, and reliability in their results timing.
So what kind of sports now you'll generally use an active system for? High-speed cycling, like road cycling or mountain bike downhill. Cross-country skiing and downhill skiing. So generally for downhill and also for cycling, you'll only use the chips as support for your photo finish or photo cells to process the results faster. You'll use it at high-profile triathlon events, on obstacle races, especially if they're really muddy, because as we said, the passive system doesn't like water, whereas the active system doesn't really care. So on an obstacle race that's really muddy, if you want reliability, you should go for the active system. And of course, for motorsports, that's the preferred solution, especially karting or motocross and other more exotic kinds of events, which we'll briefly discuss now. So actual events, our active system is used at. Ironman triathlons, here we see Alistair Brownlee crossing the finish line at some Chinese event. Patrouille des Glaciers, that was in April in Switzerland, timed for the second time with the Active Pro. And this year we introduced the track boxes. So here we had 4,500 mountaineers crossing the Alps with 14 timing points at over 3,000 meters altitude for some. So that's where you really need the lightness of the setup of the active system. Tour Down Under and a lot of other cycling events in Australia especially use our active system.
So quick question there has come in. What's considered high-speed cycling? It's a good question. I would say for me, high-speed cycling is anything where you're exceeding, it's a race, I would say actually. So a sprint finish in a road race, a mountain bike downhill race. Like I said earlier, with the passive system, you could expect good reliability up to 40 kilometers an hour, but it also really depends on your specific event. So a UCI mountain bike cross country, although lower speed, would probably still have a photo finish there to verify all the positions as well. But with a high speed finish, I mean, road sprinters going up to 60, 70 k an hour plus, you won't get the same precision and reliability of order of results with a passive system as you do with the active system. So there is no definitive answer we could give you for that, but anything where you require that high precision of timing is what we really mean by high speed, I guess, as well. So another question, max speed detection for the active chip for motorsports. So I believe it's 250 kilometers an hour is in our data sheet. For those of you in miles an hour, I'm not very good at maths today.
So
Hugo's just loading our data sheet.
Yep, because I don't want to say anything wrong. Let's just make it
French is fine, I can read it.
English. That might be easier for our viewers. So if you look up the system section of our website, it's in the data sheet. Page 7, if I remember correctly.
I'm impressed.
All right, page 8. So maximum speed for the active motor, 250 kilometers per hour. With the Active Pro V2, 150. With the Active Basic, 75 kilometers per hour. But at those speeds, with an accuracy of 0.2 of a second, you really don't want to be using the Active Basic transponder.
Okay. Yep. So that's cycling, and we already briefly touched on it.
Okay. Another popular use case that's really growing at the moment for us is karting tracks, and also karting competitions. And finally, we'll see a use case that's in Australia, dinghy boat racing. That's a picture from the Red Bull Dinghy Derby that happens at the beginning of February down under. So here you see that's the finish line, and we have one of our volunteers setting up loop boxes on a rope. So again, that's the finish line, so we need accuracy. That's why we're using a loop box. But then they have also long courses with some where they want to see if the boats have made it to some creek, and that's where the loop boxes are, the track boxes, sorry, are very handy, because instead of standing on a boat and carrying a loop across, which you could realistically only do for a couple of splits, then you can very easily lay dozens of track boxes along the course and get the detections precise to a couple of seconds everywhere along the track.
So that pretty much covers our hardware and its applications. Is there anybody who has got any questions, maybe some specific use scenarios they're not sure on what they should be using, or other general setup questions? Please do send them in. But as always, you can always send your questions to us at support@raceresult.com as well. Normally me or Ugo will answer you pretty quickly, and we've got other support team members with us. But if you have any questions, send them in to us. Hopefully this gives you a better idea of the best use for your hardware. Maybe you're thinking about moving between passive and active and you're not sure which one you should be using. Or if you're a new customer who's watching this later on, hopefully now you have a better understanding about the hardware options available to you for race timing. Particularly if you're new to the market, it can be a bit daunting. So thank you very much for tuning in, and we look forward to hearing from you soon.